Hi, my name is Brandon from Professor Bradbury's Chem 112, and today I'm going to show you the valence bond theory of arsenic 5 iodide, which includes the Vesper diagram, hybridization, electron box diagram, and the contour diagram. I want to begin with the Lewis dot structure for arsenic 5 iodide. As we can see, there are 5 valence electrons for arsenic, and there's 7 valence electrons for arsenic. But since there are 5 iodide, we have to multiply the 7 valence electrons from iodide times 5, giving us a total of 35 valence electrons for iodide. And then we had to add 35 with the 5, giving us a total of 40 valence electrons. And below this is the Lewis dot structure for arsenic 5 iodide. Okay, now I want to move on to a different page with the drawing of the Lewis dot structure to determine the molecular geometry. Now here's a bigger picture of the Lewis dot structure. As we can tell, it's going to be a trigonal bipyramidal because there are 5 bonding pairs. 1, 2, 3, 4, 5. And then there's going to be no lone pairs, as we can see, because all these dots are bonding with. On the bottom, it's kind of a picture of me trying to prove to you that this is a trigonal bipyramidal because there are 5 bonding pair and 5 bonding pair and 0 lone pair, which makes it a trigonal bipyramidal. Now in the next clip, I want to show you the Vesper diagram of arsenic 5 iodide to see how it would look in the trigonal bipyramid form. Now here's a Vesper diagram of a trigonal bipyramidal. Here you can see a trigonal shape which forms a axial angle, which is a 90-degree angle, and a equatorial, which is 120 degrees. Alright, in the next clip, you can see, I'm going to show you a model kit that can help you show you the axial angle a lot better, the equatorial angle a lot better, and can also help you see the trigonal shape of the molecular geometry. Alright, so here are the model kits. Let me label them first. Alright, now that you can see that you can see more of like axial angle, which is right here, a 90-degree angle right there. And then you can also see the equatorial angle from this lateral view, from this upper view, right there. Also, you can see a trigonal shape from this upper view. And on the left is a digital model, which is pretty much the same thing. You could see the 90 angle right here and the equatorial from right there. Now in the next clip, we're going to move on to the electron box diagram. Now in the electron box, we start with the ground state of arsenic. We have two pairs. We have a pair of 4s electrons and 1, 2, 3 separate electrons in the 4p orbital. Not 4d, 4p orbital. And then one electron from the 4s would promote onto the excited state. So now we would have 1, 2, 3, 4, 5 separate electrons in the excited state of arsenic. Now we're going to move on to hybridization. Now we're in the bonded state of arsenic. The hybrid orbital would be sp3d due to the molecular geometry, it being trigonal bipyramidal. So there would be 1, 2, 3, 4, 5 spaces. And these electrons would be from the ones that are being promoted. Now, here is the electron configuration for iodide. This is going to be the 5p orbital, and we're only concerned with the 5p because this is where we bond with arsenic. Now we're going to multiply iodide by 5 because there are only 5 iodide in arsenic. 5 iodide. So we're gonna share electrons with the one that's not paired. So we move it down here. One there, another one there, another one there, another one there, and another one there. And all of these are going to be shared with this one right there. And now we're going to move on to the contour diagram. Okay, so here is a contour diagram. So arsenic is going to be the central atom. And then we have to draw a line straight up there and down, and then to the side, and then to an angle. Next, we're going to draw 5 orbitals called the sp3d. And now I'm going to show the pair of electrons. Now I'm going to draw the orbitals for iodine. Now we're going to label the angles. This one is 90, which is axial, then 90 degrees. And then this one is the equatorial. Which is 120 degrees. Now we have to label the shape of this, which is a trigonal bipyramidal. Also, we have to label iodide, which is located right here in the nucleus. So I. Also, we have to label these 5P. Because there are from different 5 iodides. And that would be it for the contour diagram. Here's more of a better picture of arsenic 5 iodide, which is a trigonal bipyramidal in the contour diagram.